This is an overview of using distributed TensorFlow with Cloud Machine Learning Engine and Cloud Datalab, which are services offered through Google Cloud's platform. This tutorial utilizes the MNIST dataset, which is a large data set of hand-drawn images to train a model and then deploy that model to be able to supply it with drawn images that the user can create to test the model. So you can see here the size of the training and test data. So it's a quite large data set. So we'll be using this to create the neural network. So if I've followed these steps so far, it first has you just do some Google Cloud Platform setup and enabling some APIs that are going to be called through this process. You'll be using the Cloud Shell through Google Cloud Platform. So it has you cloning a GitHub repository that holds the data set and then setting up the bucket with that data set and then training the model, which will generate a job that'll run for 10 to 15 minutes or so, and at the output of that will be a model that, looking at the logs, this line is important. It'll give the accuracy, and so this is 0.9928, which is close to the tutorial's own 0.9931. The first time I actually ran this, my other job was a little over 0.98, so I ran it a second time to see how well it would do the second time, and I got the 0.9928. So that's the one I'm going to be using. And then afterwards, it can be visualized using TensorBoard, which I did. That port's closed though, so I'm not able to view that, but my graph looked similar to this one, though it had some ups and downs as it was going through the optimization of the loss function. And then after that, you can actually deploy the model out. So this deploys the trained model, that second one that I'm using. And then this is just some tests that you can do to make sure that it deploy out correctly before moving on to Google Cloud's Datalab. So this is the stage that I'm at right now. I have created a session using Google Cloud's Datalab, which actually, it doesn't state here, but it requires another API that might have to be enabled. And unlike TensorFlow, which uses port 8080, this uses port 8081. So that's why I closed the TensorFlow port. So at this point, I can now create a new Jupyter notebook. That's going to open a new tab with a new notebook. So the first thing we'll be doing is running this set of bash shell commands. So I'm just copy to clipboard, paste that in there, and then run this cell. See here it's running. And so this is a successful run generation. So now I need to reload this page and confirm the reload. So it's going to now output some JavaScript code. So this is a sign that the previous bash shell commands did successfully run. Should get this set up here, which will create this interactable box, and then these two cells right here, which will run after drawing a number and using prediction and then a visualization of that prediction. So now at this stage, I could, using the model that I've trained and deploy, I can test it. So I can, for instance, draw see here, clear. Oh, I need to actually run that. This was generation a previous just output. So now here you can see I can draw a 7. So now what I'll need to do is run this line and then, or this cell and then this cell. So this first cell is actually doing the prediction. So what will come back will be a class, which is the prediction, but then also the probabilities is just a matrices of the actual weighted predictions. So it's not displayed here as well as it could be, but you can visualize this as it's 10 numbers. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you can see all these numbers are actually quite small there, with the to the negative 15th. So the one that comes back closest to 1 is 7.99999033. So that came back as 7. So that was a successful prediction, and then we can run this cell right here to visualize that. And so you can see here on a scale of 0 to 1, all those other ones were, are quite close to 0. They're quite small numbers, so they are all at 0. And then 7, which was 0.9999, came back very close to 1 here. So that shows it on this bar graph. So you can keep running this, more prediction tests. So actually, this is the way I would do a 7, and this is the way I would do a 1. But some people do a 1 this way, which this part could be kind of close to a 7. So I'd be interested in seeing how the model handles that. So what I'm going to do here is run this cell again. All right, so it did come back as 1. So this is 1, but it did get it at only 0.767. And then, so 0, 1, 2, 3, 4, 5, 6, 7. So this is 7. That's still quite small. Actually, it looks like it was somewhat close to thinking that it was a 9, or actually even a 2. This isn't as small as this 3. There isn't as small as we saw the other one, which was a lot of negative 15s and such. So, and you can see here how close it thought that it was getting to a 9. I guess maybe that also could have seen this as a 9, since the only other thing it would have needed would have been this, and not needing this. So let's try a 9 and see how well that does. So came back as a 9. See, negative 13, negative 13, negative 7, negative 9, negative 6, negative 12, negative 14, negative 6, and then see, it got close to 8, but that does make some sense. Is this the top loop, and then but it got to a 9 quite close, 0.9987. So you can see here in this visualization that it pretty overwhelmingly thinks that it's a 9. So yeah, that's a quick overview of this tutorial that Google Cloud provides using TensorFlow, a distributed TensorFlow, and Google Cloud Machine Learning Engine and Cloud Datalab to run it and test it.